we're going to derive what is known as the quotient theorem. If Q for quotient is a quotient, one function over another function, then Q prime of x is equal to the derivative of the top times the bottom minus the top times the derivative of the bottom. Just like the quotient rule, product rule. Exactly like the product rule, except there's a plus in the middle. And in the bottom, you divide by the bottom square. And of course, we're going to prove this using the definition. Q prime of x is equal to the limit as h goes to 0 of Q of x plus h minus Q of x over h. And this is going to equal the limit as h goes to 0 of, well, Q of anything is f of anything divided by the g of the anything. So it's f of x plus h over g of x plus h minus q of x, which is outright given. And this is all over h. Now, somehow we want to get this to look like, say, the derivative of f. So this is the limit as h goes to 0. The reason we want to do that is, unlike the first person who derived this formula, we have the benefit of knowing that we want f prime of x. And it's going to turn out that it's going to be multiplied by g of x. We know this. So this is somewhat easy for us. So we have f of x plus h over g of x plus h. Now, out of nowhere, I am going to take away f of x over g of x plus h. And the reason is because it's going to have a common denominator, and the top is going to start looking like the derivative. We just need somehow to get an h over there. So I took that away out of nowhere, so then I have to add it back. Plus f of x over g of x plus h. And let's not forget to take this away. Minus f of x over g of x. And all of this gets divided by h. Okay, so let's see what happens. So we have the limit as h goes to 0 of f of x plus h minus f of x. If you know your algebra well, these get multiplied. That is, I can switch them over h all over g of x plus h. Plus, looks to me like I can factor out an f of x here. Hold on. Okay. So here I factor out an f of x, and what I get is 1 over g of x plus h minus 1 over g of x. And of course, this also gets divided by h. Okay. Now, the first limit, so limit of a fraction is the fraction of the limits. This is the limit. Oh, first, let's distribute the limit. So the limit as h goes to 0 of f of x plus h minus f of x over h over g of x plus h plus the limit of the second term, f of x times 1 over g of x plus h minus 1 over g of x all over h. Now, for this limit, it's the limit of the top which starts to look real promising, divided by the limit of the bottom. Plus, I'll write this as a product. This one, the limit of f of x times the limit of the second factor. One over g of x plus h minus 1 over g of x all over h. Okay, let's see what happens. Now, this top limit, really friendly. It's f prime of x. The bottom limit, I do have a typo. Remember, it was g of x plus h. But we already proved a couple of minutes ago that that limit, as long as g is differentiable, that limit is just g of x. Okay. Plus, this limit, well, that's just f of x, because it has nothing to do with h's. Alright, now, the next limit, that's where we have to do some work. Let us get a common denominator. Okay, so, times the limit as h goes to 0. Well, let's just get a common denominator for that. So, it's going to be g of x minus g of x plus h all over g of x. Let's do it in the order that we have it. G of x plus h times g of x. And all of this gets divided by h. So we have f prime of x over g of x plus f of x times this limit. Now, I could interchange those two. This is the limit as h goes to 0 of g of x minus g of x plus h all over h divided by g of x plus h times g of x. Okay. Almost done. F prime of x over g of x plus f of x. Now, in fact, I'm going to factor out a minus sign from that limit. I'm going to factor out a minus sign from here. So what I get is g of x plus h minus g of x over h all over g of x plus h times g of x. Okay, and this is equal to f prime of x times g of x minus f of x times the limit of the top, g of x plus h minus g of x over h divided by the limit of the bottom. Okay, so we have f prime of x over g of x minus f of x times. Well, the limit of the top, that's just g prime of x divided by the limit of the bottom. this is a constant. It has nothing to do with h, but this does. So it's just going to be the constant times the limit. And if g is differentiable, we prove that that's just g of x. Okay. Now, let's just get those fractions that have common denominators. Let's multiply the top and the bottom by g of x. And then we get f prime of x times g of x minus f prime f g prime minus f g prime over the common denominator, g of x times g of x, which is g of x squared. Again, this here is the quotient rule. And the product rule, if you write it the way I suggest, is exactly like the quotient rule. It's exactly like the quotient rule, except that's a plus and there's no bottom. Okay. So in the end, let us have the quotient rule in front of us. All over g of x squared. Again, you write down the two functions. Now this only works with two functions. Plus or minus. Top, write down the top first. Okay? So derive the first, then derive the second, or derive the top, divide, and then you derive the bottom, all over this. That completes the quotient.